Welcome to GraphiteHub's interview series, a series dedicated to all things graphite. Now, today we're joined by Sebastian Pohlmann, Chief Technology Officer at Up Catalyst. So, welcome to the series, Sebastian.
Thanks for having me, Harry.
Now, many in our audience might not be familiar with Up Catalyst. It's an Estonian company working on some really innovative approaches to graphite production. So, I think it might be useful if we just start off with the basics. So, if you wouldn't mind just providing a high level overview of Up Catalyst and the work that you're doing in the graphite industry.
Sure. Up Catalyst is a small startup from Estonia. We are around 6 years old now. And what we do is we make graphite and nanotubes, generally specialty carbon materials, from CO₂ directly. So we take CO₂, we electrolyze it back into carbon and oxygen. And if you do it just right, you can get out graphite or nanotubes.
Okay, it sounds quite unique the way you're doing it with your CO2 as a feedstock. Would you mind maybe going into a little bit more detail on actually how that works?
Yeah, of course. So what we do is we take CO₂ that normally would be emitted, for example, biogenic CO₂ from biogas or from waste to power applications. That CO₂ is then introduced into our molten salt electrolysis process. So that's a process that operates in a molten salt. It's relatively hot, but not as hot as the traditional synthetic graphite processes. So we're talking about something below our 800 degrees Celsius here. And in that process, you have a molten salt bath, which is able to dissolve CO₂. And you have two electrodes in there. And on one electrode, you get solid carbon deposited. And on the other electrode, you have oxygen evolution. So you split the CO₂ back into carbon and oxygen. You basically do a reverse burn. And the solid carbon that you get out, if you set the process correctly, you choose the right temperature, the right voltage, the right current and everything, then you can get out nanotubes, you can get out graphite, you can get out different carbon materials. And that's the secret sauce in our process as well.
Right, okay, that sounds quite fascinating. And you touched there on a lower operating temperature. So, how much of an advantage is that in terms of the cost and carbon footprint?
In terms of carbon footprint, of course, it's a huge advantage to start with a non-fossil feedstock, actually the opposite of a fossil feedstock, right? Because our feedstock is CO₂ that otherwise would be emitted. So we start with a carbon negative feedstock. And a climate positive feedstock, so to say. So we use around 4 kilograms of CO₂ for every kilogram of carbon that we make. That is alone already quite carbon negative. But then, of course, the energy requirements are very interesting as well, because from energy requirement, we have the electrolysis and the heating energy, and of course, insulating something from heat losses at around 800 degrees Celsius is much easier than insulating it from 2,800 degrees Celsius that you have in graphite production. That being said, in order to make our graphite, later battery-grade graphite, we also still have to heat it up one more time to a little bit higher temperature to clean it. But that is really just the cleaning process, not the graphitization process like you normally have it in the making of synthetic graphite from needle coke.
Okay, no, it's really interesting. And then, so looking ahead, we see, scaling up is quite a challenge for emerging technologies. So, in terms of moving to full scale production, which I understand is 30,000 tons a year by 2030, what are the key steps that need to happen between now and then?
Yeah, it is indeed a big challenge, especially for a small company like ourselves. So we are today just under 40 people in the company. And of course, with 40 people, you don't build a 30 kiloton graphite plant just yet. But what we're doing on the way there is we are deploying the technology in different pilot and demonstration stages. So what we have done so far, we have demonstrated, and that we actually unveiled quite recently here, even with the representatives of the European Commission here being on at our plant. We unveiled a pilot reactor that has 2 large electrolysis cells and that can every day produce multiple kilograms of nanotubes. And if the same technology can, of course, be used to make graphite. So the next big step is to switch our production process into a continuous process where we continuously remove the solid carbon from the electrode. And then to scale this up, we plan to have the first at-scale electrolysis cell for this actually ready in around 2027. The good thing about electrolysis is and that you see in the production of aluminum, of magnesium, things that humankind has done for hundreds of years, is you can replicate electrolysis in unit cells. So you basically have one unit cell and you build a lot of those unit cells, you automate them, and that's how you get the scale and the price done. That is then after 2027 our main effort to actually design and build the first large plant. And whether it's then going to be 30 kilotons per year of graphite, or whether it's going to be 20 kilotons or 40 kilotons, depends also on the customer requirements, right? So why we picked this number, it's not an arbitrary number of 30 kilotons, it's roughly what you need to fulfill the demand of graphite for 1 gigafactory. That's why we chose that.
Okay, and then maybe on the note of customers, what industries or your customers do you see as the primary market for your graphite?
So, of course, the largest market is the battery industry, especially the European battery industry, which is at the moment entirely dependent on graphite being imported. And of course, graphite being imported from Asia mostly. That is, of course, a supply chain risk, but it's also a strategic risk in terms of geopolitics if you look at today's situation. And that is something that, of course, the battery industry is quite interested in, to have a look at domestic supply of graphite, especially considering that in a lithium-ion battery, we call them lithium-ion batteries, but actually around 25 weight% of the battery is graphite. So they could also be called graphite batteries because there's much more graphite in them than the lithium.
Let's start a
That
petition.
is, yeah, exactly. But that is one of the biggest markets, of course, because every electric vehicle that you want to build needs around 50, 60 kilograms of graphite, depending on the battery size. But there are other markets, other very interesting markets on the road to scale, so to say, because while the battery market is the largest for scale, then there are markets for graphite as a conductive additive, graphite as a specialty chemical. And since our graphite is very pure, so we have achieved purity in the graphite of over 4N, so 99.99%. And that is interesting just from graphite powder applications as well, which we're currently looking into as kind of stepping stones to that large-scale battery market.
Okay, no, it sounds like there's a lot of opportunities out there, and yeah, we look forward to tracking the progress. So yeah, it's been fantastic to have you on here today, Sebastian. Fascinating insights on just hearing how graphite can be made from alternative ways. Appreciate your time, and we look forward to having you again on here sometime soon.
Thank you, Harry. Looking forward to it.
Great. Thanks everyone for tuning into this episode of Graphite Hub's interview series. We'll see you next time.